Hey guys, so welcome to chapter 5. Um, so this is 5.1. The title of section 5.1 is composite functions, okay? And you've seen this before. So it should be a fairly easy lecture today. So the first thing we're going to define is composite function. What is a composite function? Okay, so here we go. Given two functions, f and another function g. Composite function. So can you see that? There you go. Composite function, which is denoted by f bubble g. So it looks like fog, but it's f bubble g. So if it's a closed circle, then it's a multiplication. But if it's an open circle, then it's composition. Okay. You can read f composed with g. I want to make sure you're able to see all of this. When I zoom in too much, it usually cuts the slides, which I don't, which I'm trying to, make sure that it doesn't do that. So this is read f compose with g, or f of g. Okay, is defined by, so when you see f bubble g of x, it means it's f of g of x. Okay, so you're gonna take the input, the f input is the whole function, the g of x function. Okay, and we're gonna period right there. Okay, let me see. There you go. The domain of f composed with g is the set of all numbers x in the domain of g such that g of x is in the domain of f. Okay, so that sounds really confusing. Okay, so the domain said, hey, the domain of f composed of g is the set of all numbers x in the domain of g. So whatever the domain of g is, okay, is now in the domain of f. So we're going to take into account, so the domain of the entire composition here, you're going to take into account of g of x and then f of x as well. Okay, and then we're going to do a couple examples later of what that really means. Ooh, look at that light. My window is projecting some weird light right there. Okay, look at this. That's so cool. All right. So later we're going to do some examples of how to find the domain of the composite function. But right now we're just going to do something easy. Okay. All right. Moving on. We are going to go to example 1. I want to zoom in as much as I can. Let me just go close that window. So hold on. All right, here we go. Example 1. Let's zoom in on A first. Okay. Evaluate 1i f of g of f of negative 2, or g composed of f of negative 2. 2i's f composed of g of 0. 3i's f composed of itself of negative 1. And 4i's g composed of itself of negative 3. So you're given an f and a g function here. These are order pairs. Okay, so a set of order pairs. And they're supposed to be a function, so none of the x values should repeat. Okay, so we're going to do 1i first. I'm going to do 1i and 2i's, and then I'm going to leave 3i's and 4i's for you to finish on your own. Okay, So it says, hey, f, so by definition, 1i means f composed of, sorry, g composed of f of negative 2 is the same as g of f of negative 2. Okay, so the first thing I need to find is f of negative 2. Oops, you can't see that. There you go. Ooh, 1i. Okay, so by definition, g composed of f of negative 2 is the same as g of f of negative 2. So by definition, I'm going to first find f of negative 2. This one, it's the f function. When the input is 2, the output is 3. So I'm just finding out, I'm going to look at the input. Which one has an input of negative 2? So the input negative 2, the output is 3. So now f of negative 2 is 3. So that's what I'm going to compose with. So now g of 3 is my second step. Okay? So this is what you have to do first. So g of 3, now I'm going to go look at g. So which one has an input of 3? Oh, this last piece. This last piece has an input of 3. So input of 3, output is 1. So g of f of negative 2 equals 1. And you do have to write the original problem and give me the answer. Okay? Alright, so let's do 2i. You know what? Why don't you go and do 2i on your own? So go ahead and pause it for me. Do 2i on your own. On your own. Okay? And when I see your notes, when I stamp your notes, you should have this completed. Okay? So now I'm going to go and try to pause it right now. Okay? I need you to pause. Do 2i. Once you're done, then hit play so you can look at 3i. Alright, 3i says I need you to do f of itself. So f composed of itself of negative 1. So by definition, it's f of negative 1. So the first thing I'm going to do is I'm going to take f of negative 1 first. So I'm going to look at the f function. Where is my negative 1 input? So this is my negative 1 input. The output is going to be 1. Okay, so that's my output of 1. So the second piece is I'm going to take f. Okay, this is now 1. So I'm going to do f of 1. F of 1, do I have an input of 1? Here it is, an input of 1. So the output is negative 1. I'm only using the f function because this one says it's f of negative 1. So when I write the original problem, my answer is negative 1. Okay, then now let's go do 4i's. And if you remember, 4i says do g of negative 3. Okay, so here we go. 4i, g of negative 3. By definition, it's g of negative 3. The first thing I'm going to do is I'm going to look at the g function, and the input is negative 3. Okay, so here we go. And it happens to be the first order pair. Input of negative 3, output is 1. Then the next thing I'm going to do is take this out. I'm going to compose. So now g of 1. So that's not the input of 1. Nope, that's input of negative 1, which is not what we want. Input of 0, input of 2, input of 3. I do not have an input of 1. This doesn't have a solution in my g function. So therefore, how do I write my answer? G composed of g of negative 3 does not, oops, what am I saying? Has no solution. Okay. What am I doing? I don't want a double negative, so equals 2. Okay, so equal, oh, that looks like a happy face. Or not a happy face, but is that like an I don't care face? Okay, so equal, sorry, this is an equal sign. So g composed of g of negative 3 equals to no solution. Okay. Alright, if I'm going too fast, please do pause, okay, and then rewind, or you can listen to it again the second time if you need to. Alright. Okay, so let's look at B. We're going to do the same 4 steps on B, but B is giving you the f function as a graph, and the g function is also another graph. Okay, so 1i. 1i sets, I need you to find f composed of f of -2. So this is your f function right here. Okay, the darker one. I think if you have color printer, it's printing a different color. So when f is -2, because that's my first thing, f of -2, well, my f doesn't go to -2. Okay, so this immediately doesn't have a solution. Okay, so f composed of f of -2 has no solution, therefore I can't go any further. The whole thing doesn't have a solution. So isn't that the nice piece? Okay, so now let's do 2i. I would like to do this on your, oops, I spelled on your own all in one word. So you and your and own. Okay, so do 2i on your own. Then I'll do 3i. So go ahead and pause right now. Finish up 2i on your own. Then hit play so you can see 3i's. Okay, 3i says, I would like for you to find f of -1. So f of -1. Okay, so by definition, I'm going to find f of -1 this way. So the first thing I want to do is f of -1. Well, similarly to 1i, I don't have any negative value on f function. So already this doesn't have a solution. Therefore, f of -1 equal to no solution. Okay. All right. Then 4i says, I would like for you to find g of g of -3. Okay. So g of -3, so by definition is g of -3. The first thing we're going to find is g of -3. Okay, so let's check out a g function, which is in my black and white. It's the lighter one. So when x is -3, okay, I'm going to go up. Let's see what that is. If I have to guess, the output is about 3. When the input is -3, the output is about +3. Okay, so I'm going to have a +3. Then the second piece, I'm going to take g of +3. Okay. So g of +3, now so this is now in here. So I'm going to go 1, 2, 3. When the input is 3, let's see how far I can go. Okay, what's my output? 1, 2, 3, 4. Looks like it's +4. So to write my final answer, g of -3 equals to +4. Okay. All right, so hopefully by now you got an idea of how to find the composition of functions given a set of ordered pairs and two different graphs. Okay, so now we're going to flip to example 2. Actually, you know what? I'm going to stop right here. And then I'm just going to do example 2 on a different video. Do you guys want to hear a joke? So let's see, what joke should I tell today? Let's see. What do you call an animal with one horn that asks too many questions? It's called a rhinoceros. So instead of a one-horn animal, well, what animal has one horn? Usually I think of a rhinoceros, right? A rhinoceros. But because it has too many questions, we give it as a rhinoceros. All right, that's my toddler joke for today. See you next time.